Texan Global School. In this class, we will analyze intervals. The intervals express subsets of the real numbers that correspond to a segment of the number line geometrically. There are three general ways to represent intervals. The first is in the form of an ordered interval, enclosed by parentheses or brackets. The second is by using set comprehension notation. The last one, in graphic form, is a segment of the number line. We will discuss each of the four types of intervals: open, closed, mixed, and infinite. The open interval is a type of ordered interval that is enclosed in parentheses. Its set by comprehension uses the symbols greater than and less than. Graphically, the ends of the segment contain an unfilled point. All three representations indicate precisely the same thing. In this case, the variable x represents all the values greater than the element a and less than element b. The elements a and b do not belong to this interval. The closed interval is a type of ordered interval that is enclosed with square brackets. Its set by comprehension uses the symbols greater than or equal to and less than or equal to. Graphically, the ends of the segment contain a filled point as shown. These representations indicate that the variable x represents all values greater than or equal to the element a and less than or equal to element b. The elements a and b do belong to this interval. Let's look at a first example. They ask us to identify the type of interval and to represent the two missing symbologies. We will make a brief description of the elements of the set. As we can see, it is an interval closed by both ends since it is bounded with square brackets. Their representation as sets by comprehension, and their graph represent all values greater than 2 and less than 3, including 2 and 3. Some examples of elements that belong to this interval are 2, 2.01, 2.3, 2.85, 2.999, 3. In the second example, we can see an open interval since the set by comprehension uses the symbols greater than and less than. Its representation as an ordered interval and its graph represent all values greater than -1 and less than 2, but they do not include -1 or 2. Some examples of elements that belong to this interval are -0.9, -0.58, 0, 1, 1.999. The mixed interval is one composed of the combination of an open interval and a closed interval. Like the previous ones, it is represented in three ways that have the same meaning. We can have a mixed interval, open on the left and closed on the right as shown on the blackboard. These three representations of mixed interval indicate that the variable x represents all values greater than element a and less than or equal to element b. Element a does not belong to the interval, but element b does belong to this interval. The other case of a mixed interval is closed on the left and open on the right, as shown. This interval represents all values greater than or equal to element a and less than element b. Element a does belong to the interval, but element b does not belong to this interval. Let's look at an example. The indicated interval is a mixed interval, open on the left and closed on the right. Its representation as a set by comprehension is x, such that x represents all those values greater than -3 and less than or equal to 7. Some examples of elements that belong to this interval are -2.9, -1, 0, 1/3, pi, 5, 6.9997. Recall that pi is an irrational number equal to 3.14159, etc. Within the infinite intervals, we can represent the set of real numbers with the analyzed notation, from -infinity to +infinity, or x, such that x belongs to the set of real numbers. Graphically, its representation shows all the points on the number line. There are four combinations of infinite intervals. The first case, open on the left to infinity, represents all values greater than element a without a belonging to the interval. The second case, closed from the left to +infinity, represents all values greater than or equal to element a, which does belong to the interval. The following case, opened on the right from -infinity, represents all values less than element b, without b belonging to the interval. The last case, closed on the right from -infinity, represents all values less than or equal to element b, which does belong to the interval. Let's look at another example. We will identify the type of interval and represent the two missing symbologies with a short description of the interval. As we can see, it is an infinite interval, open on the right. Its representation as a set by comprehension is x, such that x represents all values less than -2. Graphically, its representation is shown on the blackboard. This interval represents all values less than -2. Some examples of elements that belong to this interval are -2.01, -3, -500, and so on. In this last example, we can see that it is also an infinite interval, but closed on the left. This interval represents all values greater than or equal to 0. Some examples of items that belong to this interval are 0, 0.005, 1, 3/2, 2, 30, 140. Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com